To the left right here, this is the scene tree, which defines every single object within the simulation. And to the bottom, there's a console. And to the very left, this is the Erebus custom UI, which allows you to load controllers and play and pause. So to start, we're going to reiterate many of the things that you guys, if you've seen the video, will see. So to start off, we can zoom in with the scroll wheel. And if we zoom in on this robot right here and left click on it, it's going to highlight it as well as reveal its 3 transforms. So we can move it around by clicking and dragging on one of the transforms, and it tells you exactly how much you're moving it, like 1 meter exactly, or that was exactly 1 meter. But we can revert to what back with Control Z. And also, if you just want to move the robot horizontally while locking its height, you can hold Shift. I'm holding left Shift and left click on it, and you can drag it around like so. And this will lock the horizontal movement, so it's not going to go up or down, but it's going to move horizontally. All right. You can also lock its horizontal movement and only move its height by holding left shift and either the middle mouse button or both left and right click at the same time, and that allows you to move it up and down. To rotate the object, you can see these symbols attached to each transform, these rotation symbols. That allows you to rotate around a particular axis. So for instance, if you want to rotate around the y-axis, we can click on the symbol and then drag it, and it's going to specify the amount of radians we want to rotate. You can also achieve the same thing with holding left shift and right click and drag in order to rotate the object around the world's vertical axis. To resize an object, we can click on it, right? For instance, this wall, and we see its transform. If I hold left control, it's going to reveal 3 different axes, different from the normal ones we see. And these allow you to click and drag to resize the object. But if you played around with it, you'll notice that if I do the same thing for this robot, I hold left control, nothing changes. I'm holding left control right now. That's because this robot is set to be not resizable. It's not scalable. And that's per the game rules. So we can't resize this robot as a user. Okay, so next I'm going to talk about the scene tree. So to the left, this defines, once again, every single object within the simulation world. And if I click on the robot here, you'll notice that it highlights it within the scene tree. And if I click to expand, this reveals all its like associated properties, including the translation, rotation that we changed before, as well as its like robot controller and all the sensors that are attached to this robot. So for instance, we have a gyro, we have an IR receiver, an IR emitter, a light sensor, a GPS, and a camera. So all of these sensors you'll be using within the Erebus game. We can also modify the robot's translation fields directly within the scene tree. So you'll notice it pops up right here, and we can change it manually. And you'll notice that it changes within the simulation view as well. So now we're going to try to add our own custom object to the simulation world. So first thing, before you add an object of your own, is to make sure, first of all, that the world time is set to 0 and the game is paused. Make sure that it's set to 0 so the world will not be running. And if you press this button, that just resets the world, so you know it's at time equals 0. To add an object, we can right click within the scene tree and we just hit add new. So Webots defines, it's very convenient because it defines a lot of proto nodes, and what those are Webots has created a bunch of textures and objects for you guys to use. And there's a whole bunch of things. There's a bunch of
textures,
objects that for building your environments, we can add a soccer ball just to test it out. And you'll notice that the soccer ball appears in the simulation. So if I click on the soccer ball and drag it up, and I start the simulation, you'll notice that the soccer ball bounces down, as so. I can also hold, while the simulation is running, I can hold left Alt, click and drag on the object, and it applies a force to the soccer ball. All right, so let me pause and reset. Okay, so now, like in the video, I'm going to hand it back to Jeffrey, and he's going to talk about everything else.
So this window down here, we call this the console window. This is where all of your prints are going to print out to. So if your code prints any numbers or messages, or if you run anything, any command line commands will be executed and their prints will be printed out to this console window right here. So if you want to clear all the text inside this console window, you can always just right click, hit clear console, or you can hit Control K, and all the text will be cleared so you can see a little better. So that's the console window. So up here, you will see a toolbar of many buttons. We're only going to cover some buttons in this video, and they're the ones that you absolutely need to work with Webots. So as Victor said before, you can see the world over here, and this world, the state, is saved in a file. We call it a world file. So the position of each object inside this world is going to be saved inside that world file. Now, let's say you created your own world file. If you don't know how to, there's a tutorial in Webots we'll talk about a little bit later. But let's say you created your own world, you can open that world using this button right here. So someone's annotating, so if you could not, that'd be nice, because everyone can see it, I think. Anyways, now, the state of this world is saved in the world file, like I said before. Now, let's say you want to edit the world, such as add an object, as Victor said before, and you want to save those edits. Let's say I want to move this robot, right? As Victor said before, you should always make sure that this timer right here is set to 0. If it's not, you can always hit the reset simulation button, and it should bring this timer back down. Now, let's say I want to move my robot so that it's here, and I want to save my world, so every time I open the world, the robot is at that position. I would just hit save world. So yeah, now this is the reload world button, and basically what it does is it regenerates the world as if you closed out of Webots and reopened it. So these 3 buttons are for world interactions. Now, these buttons over here are for running and resetting the simulation. However, if you're using the Erebus world, they have created a very nice user interface for you. And the user interface has a play, pause, and reset button. That means you don't need to use these buttons over here. However, if you're using your own world that you created, this window over here, this simulation controls, is not going to be here for you. So in that case, you would use these buttons over here, in which case this is the pause and play button, and this is the reset simulation button. As you can see, it brought the robot back to before, so it reset the simulation. So now, I'm going to go into a little detail about this window over here. We call it the Erebus user interface. So first things first is you will see that in this world, there are 2 robots. And thus, over here, you have robot 0 and robot 1. To figure out which one is which, you can just click on it, and it will light up as robot 1. So you know that this robot right here is robot 1. So I'm going to work with this one, and therefore I'm going to use this side of the Erebus UI. So now, how Webots basically works is you have a world, and inside that world, you can create robots, and you can link code to robots. We call that code controllers. So when you say load controller, it's basically loading code to this particular robot. So let's say I want to load a Python script. So this robot can run that Python script. All I would have to do is click on load controller for robot 1. It'll bring up my files, and I can select my Python script. Now, when I double click on it, you will see that it loaded the controller, and you know that because it highlighted red. Now, this robot right here now has the Python script connected to it. So when I hit run simulation, it will run that Python script. So as you can see, when I hit play, this runs the simulation. You can see that my simulation starts to go, and this timer starts to tick. Now, I can pause the simulation, and as you can see, everything freezes. Now, I can reset the simulation just like the reset simulation button over here. And since this UI is provided for you, I would just stick to these 3 buttons over here instead of these buttons over here. So now, this right here is your scoreboard. So let's say that I run my simulation. You can see that a whole bunch of humans pop up in the world. This is how the game works. If you're unfamiliar with how the game works, I suggest you read the rules after this tutorial. So let's say my robot comes over here and picks up a human. Obviously, during the competition, you're going to have to do this with code, not by dragging and dropping. But as you can see, my robot picked up a human and it disappeared. In the scoreboard, you will see that it says picked up a human, and this guy lit up orange. That means you have a human actively on you. Now, let's say he goes back all the way to base, as you're supposed to do, and it drops him off. As you can see, that it says brought a human back to safety, and this guy lit up gray, which means it dropped off its human. And then your code will go back, and it will update your points right here accordingly. So that is the Erebus user interface. To quickly recap, you have load controller for each robot. These are your play, pause, and reset simulation buttons. And this right here is your scoreboard and timer. So now we're going to talk a little bit about the folder hierarchy for the Erebus competition. So when you downloaded the folder, as instructed in the video, off of their GitHub page, you should have downloaded an Erebus Aura folder. And inside, it will have all the files necessary to run your code and compete. So you need to mainly deal with 2 folders only. The first one is the game folder, and the second one is the player controllers folder. So Ethan, if you have a question, you can just message the moderator, and she will get it for you.
I'm sorry, hold on a second. I'm sorry, interrupting. Everybody, okay, I need you stop doodling. I'm sorry, if I see that again, I'm going to remove you. Okay, so this is actually quite disruptive. You do that, so please not to do that. Okay, I'm sorry. Jeffrey, go ahead.
Yeah, okay, thank you. If you doodle, everyone can see it, so it's kind of, yeah. So to continue, the 2 main folders, as I said before, that you need to deal with are the game folder and the player controllers folder. So as you can see before, I loaded a Python script so I can link it to my robot so my robot can run it. That file should be stored in the player controllers folder. So once again, the Python script or whatever code that you want to run should be saved inside the player controllers folder. As you can see, this is my code from earlier, and this is the code that I loaded into my controller. Now, let's say that my code needs other files to run. Let's say an abstraction layer or a library that has folders or methods that, that this code needs to run successfully. In other words, any header files. So if you need any supplementary files, they should not be stored in here, but they can actually be stored inside game and inside controllers. Then just select whichever robot needs that folder. For example, needs that file, sorry. For example, let's say my robot 0 needs an abstraction layer and a library to run. Remember that the robot 0 is still loading my code from this folder over here. This is the one that I'm actually loading in the controller. But this code needs other files, needs code from other files to run. So that code goes into this folder right here. For example, an abstraction layer and a library. So that is why I put these two files here. They help the code run. So the reason why you don't want to store your main code inside of this folder over here is if you save your main code into this folder right here and you run the Webots, your code is going to get wiped. So always remember, the code that you want to load inside the controller should always go in the player controllers folder. Any other files that you need to run, any header files or any supplementary Python scripts should go inside game and inside the appropriate folder, whether it be robot 0 or robot 1. So that's basically it for the basics of Webots. Remember that this little tutorial is for the basics of interacting with Webots. As you can see, we didn't cover any code, and as Ms. Elizabeth said before, we will cover that in future videos. So that's basically it. Now we're going to open up to any questions.
All right, I see a few questions. Do you mind if I share screen, Jeffrey?
Yeah, go ahead.
Okay, so one question we got is, what's the maximum number of robots we can have? For this Erebus game, you'll see that there are 2 robots already inside of the world. And considering that this is supposed to be a competition environment, normally they won't let you modify the number of robots within this game specifically. Now, if you created your own world, then you can have pretty much as many robots as you want. And this right here is a specific robot that was actually modeled off of a real life robot. It's called the Pioneer 3DX. So we just used this robot. Erebus just decided to use this robot as a base to build this game around off of. And another question somebody asked is, it says it's going to take 45 minutes to download. Okay, I assume that you're talking about Webots itself. I think the download size of Webots is around 2 gigabytes, so it might take a while depending on your internet speed. So you just have to wait. And another question, how do you create a soccer ball? So we went over creating a soccer ball before. I can just go over it once more again. So within the scene tree, you want to right click and hit add new. And I'm going to talk more about these proto nodes. So remember that Webots supplies you with a lot of predefined objects that you can use. So soccer ball is only one of them. If you go under proto nodes, as well as objects, and then under balls, click on soccer ball, and you can add it right here. That's not the, all right, my window just closed. Let me reopen that. Sorry about that.
As a quick add-on, if you want to increase your download speed, you can just connect directly via Ethernet, and that'll make it go faster.
All right. And let me share screen again. So there's also other objects you can add. Just for example, Webots has a lot of things. You can even add like pedestrians and humans. And these humans can actually move if you program to. They're technically robots that have controllers that can be attached. And Webots simulates muscles as well as motors, so you can use these humans within your game as well if you wanted to. That's just one of the things that Webots allows you to do. I don't expect anybody to actually do so within a competition, obviously, but it's a lot of fun to play around with. All right, and somebody is asking, I can't find the rules on GitHub. Where are they? So let me share screen for their GitHub website. All right, everybody can see this, right? This is the Erebus wiki page. So this, you can find all the instructions for the game. And it also tells you how to use their built-in abstraction layer, how to write a basic controller, as well as the rules. So here you can find the rules. It tells you these are preliminary rules. They aren't necessarily the rules that are going to be in the final. They're not representative of the final RoboCup Junior simulation environment rules. So this is a work in progress in terms of rules. And we had somebody asking which language is used. Webots Webots, the simulation tool, allows a wide variety of languages, including C/C++. It allows Java, Python, and I think it even allows ROS, Robotics Operating System. And so Erebus, the actual competition game, it currently supports loading and executing Python scripts and Python controllers. In the future, we're gonna hopefully add C/C++ support because we want to create our coding tutorials using C++. I hope that answers your question. And another question is, when I click on add new, the thing that pops up, I don't get that and I get something else. Okay, all I can suggest is when you hit add new, make sure, first of all, that your simulation, a lot of people forget to do this in the beginning, make sure that your simulation is completely reset. So it's at time equals 0 and your simulation is paused. At that point, hopefully you can right click on, make sure that you select the last object in the scene tree, right click on it, and add new you should be allowed to press add new. And you'll be greeted with this page. So I hope that helps. And another question is there a way we can access and watch this lesson after it is completed? Yeah, we posted a YouTube video, which is pretty much exactly what we did here today, going through getting started with Webots. So that's available on YouTube, and the link should be provided on the Webots, I mean, not the Webots, the Erebus page. All right, Jeffrey. Do you want to take over some questions?
Sure. So one of them was, I'm still a little confused about which folder. So which folder to save my code in. So let's say, I'm going to share my screen real quick. Okay, so I'm in Notepad++ right now. So let's say my main code. So as we said before, okay, so remember when I loaded my controller? So my code, let's say your code is just one file. That's the easiest example. And that file is just let's say my one code file is just this file. Then that's simple. You would want to save your code in player controllers, and that way, when you load your code, you would just load this code in. However, let's say your code is multiple files, and let us open up this code. So let's say my code now needs to import some library, right? And this library is one that you created yourself. That means I'm not going to load my actual library into here, but this code needs this file to run. In that case, I would save my library instead of inside of player controllers. Then I would save my library to game controllers and then robot1 controller, because, well, that's the robot that needs that code. So I hope that clears it up a bit. Basically, the code that you load into here, the code that you hit load controller and then click on here, this one is what goes into player controllers. Anything else goes in this folder right here, the game, controllers, and robot1 controller. Anything else goes into here. Anything else besides the stuff that you want to load into here. And the stuff that you load into here should have your main code in it. So, control.
All right, there's just somebody asking, I have OpenGL 3.1, but it needs OpenGL 3.3. How do I get the 3.3 version? I'm just gonna interrupt, sorry.
Yep.
That sounds kind of like, it might be a driver problem. So we can't troubleshoot that issue too much without knowing your specific like hardware setup and system setup and everything like that. So check your drivers, make sure they're all updated, and also try searching online because we're kind of limited in your system setup.
Victor, I'm sorry, this is Dennis. I didn't hear the question. What was the driver problem?
Yes, somebody is saying Webots didn't work on my computer. I have OpenGL 3.1, but it needs OpenGL 3.3.
Oh, yeah. Do you want me to talk to that? I can talk about that
sure.
kind of fast. Okay. Hi, I'm Dennis. I'm Elizabeth's husband at Storming Robots. And outside Storming Robots too, of course. So, yeah, OpenGL, I'm going to share my screen if that's okay.
Yeah.
Okay, I'm going to stop you. And I'm going to share. Okay, so here's the Webots user guide. It's cyberrobotics/doc/guide/system requirement, or well, the system requirements is the very first section, and it talks about the installation. And as the person correctly pointed out, it requires minimum 3.3 for OpenGL. Generally speaking, if you have an NVIDIA card or an AMD card, updating the graphics drivers card should update the OpenGL. If you have, for example, say an NVIDIA card, you can go and look up the OpenGL driver support and download the latest version that exists for Windows. According to the documentation, let me go back there. According to the documentation, if you have an Intel graphics driver, right, or if you have an Intel graphics chip, right, that would be like a lot of laptops might have that. If you have a laptop instead of a regular PC, a lot of them will opt to just use the Intel graphics driver. It looks like, at least according to the documentation here, that it might or might not work, right? It's going to depend. No matter what you do, though, you need to make sure that your graphics driver is updated. One way to figure out what your graphics driver is you can bring up what's called Device Manager. So you just type device in here and you'll see Device Manager. Click on that. I hope everyone's seeing this. You can click on that, and then you can look up, let's see, where should it be at? Display adapters. And so here, for example, I have an NVIDIA GeForce RTX 2080 on my machine at home. I don't have an Intel chip on this thing. But if you click on display adapter, you might see, and if you have, like, say, a laptop, you might see two of these. You might see an Intel adapter and an NVIDIA adapter, right? So you just need to know what your graphics card is or graphics driver is, and then try to find the appropriate driver for that. So yeah, if it's NVIDIA, you know, normally just updating the graphics driver card in general, like in NVIDIA here, if I bring up NVIDIA controls, I can have it, there's somewhere in here, I know I can actually have it do somewhere here. Actually, you know what? It does it automatically for me. I never actually bring this up to find it out. So by default, it'll automatically say, hey, I need to find it. But you can always go online to the website and just look at what the driver version is and, you know, download the latest. But if it is an Intel graphics driver, you're going to have to look at the particular graphics driver you have and see if Intel has an update for that. Another option you might try is go to OpenGL itself, which is under Kronos OpenGL Wiki Getting Started Windows. You can see the URL up there. You can just do a Google search, you'll find it. And then you can try looking here, and then there's the link for the Intel, right? And then this takes you right to the Intel download center, intel.com. And then you could look up the graphics, right? And then there's an automatically update your driver. So I would try that if it is an Intel driver, but you need to identify what the driver is first on your machine. Like I said, Device Manager is the way I normally would do it. Okay, I hope that sort of answers your question. If it's not Intel, then, you know, if it is Intel, you might have an issue. But you know, according to their documentation, it might work. But if you have NVIDIA or AMD, you should have no problems updating it and just making it work fine. All right, so that's mine. I'm done that, and I'm going to stop sharing. You guys can take it over. Did that sound like an answer to their question, Victor?
Yeah, all right, thanks.
All right.
Okay, and we have another question. The controller window doesn't work properly. It seems to give a lot of errors in the console window. Is something wrong with the Erebus window? So, let me share screen again. If you open the world and there's a bunch of errors in this bottom console window, first of all, I don't know the exact errors. You'd probably have to tell me. If you haven't even done anything yet and there's errors popping up, it might be related to your Python installation. If the errors are saying something is wrong with your Python installation, then you have to verify that you installed Python correctly and make sure you have Python 2.7 and 3.7 installed. So if that's the problem, then that's something you have to look on a Python installation guide and make sure that Python is correctly configured if you're using Windows in the path. And about this the controller or the control window to the left, If you're having trouble with that, I can suggest that first make sure, once again, your time is set to 0 and the world is fully paused and reset. That will allow you to load controllers in, as well as press play, and that should work as well. As long as you can load controllers when you have the world paused, and definitely when the time is set to 0, then that should be fine.
If I can interject real quick, the same thing happened to me where when you boot up a world, you get a bunch of error messages in the console window. I just uninstalled Webots and Python and then reinstalled everything, and then it worked fine on the second install.
Yeah,
Yeah.
going.
So if you get a bunch of red error messages, your load controller is not going to work. So and once you fix that red error messages, your load controller should appear fine. So if anything, I would try just uninstall Python and Webots and then just reinstall it.
Okay. And Atosh says, in RTX 2080, Webots is really laggy because I have an Intel graphics card and I don't have anything better. So what should I do to fix the lag? Yeah, Dennis has, yeah, he does have an RTX 2080, but I've used Webots with my laptop, my ThinkPad perfectly fine, and it works just fine on my laptop. I don't think you need a really bulky graphics card in order to run Webots or anything like that. But Dennis just so happens to have an RTX 2080, so don't pay too much attention to that.
Sorry.
This is a question from a while back. This is for storming robots specifically. I'm taking grade 7+ robotics projects, C1 and 2. Does this relate to me, or is this more advanced and relates to a specific competition? This is a specific competition. This is the Erebus competition. It's a simulation version of Maze, and they're working with the RoboCup Junior as one of the competitions. So yeah, this is not specifically storming robots related. This is a separate RoboCup Junior competition.
All right, so between now and the next meeting, hopefully you guys can finish up your Erebus installation, your Erebus and Webots installation, and fix any potential problems you have with the installation. So next week, in a few days, we'll be releasing another video, and we're going to be starting to cover the actual coding of a controller. And we're going to be doing this using C++, hopefully. So between now and then, play around with Webots, get familiar with the UI and how to interact with the simulation world. And if you want, Erebus does include a few sample programs, like a sample Python script, for an example, to run your controller. So take a look at that and see if you can load it in to one of the robots and run the simulation. And the robot should behave. It's not a very good script, it's a very basic one, but you should see the robot start to move around and do things. And yep, next week we will start getting into basic navigation and coding the motors and things like that. So that's about it.
Right, so then you hover on the rescue, take a look at the bottom, the simulation demonstration environment, and then they give you all the good information, and then they will even have a link to the VRAP as well, if you so desire to check that out as well. And then you click on the Erebus wiki. And then as you see here, I will constantly updating whenever there's a new video or new link to the meeting, they'll be all here as well. And then when you go here, they would just tell you go there, and it will post anything up latest update, what each meeting is covering, and the topics, the videos, they will post it all here. And then they also have resource link about the Dr. Hughes she's a very active participant and actually creating the game for us. And then they have the link to the tutorial, RoboCup site, and the official site for the Webots, and also this is very important, guys. This one, the RoboCup Junior forum. If you have any questions, please feel free to go to that link and then post all the questions you may have. Okay, so then because we don't want to be a one-on-one type of, that's kind of limited learning. So we want to, everybody has a question. I'm sure a galore of people are going to have similar questions like you do. So we're going to share our questions and answers. So please do to go to that robocopjunior.forum. And I'm going to click on that anyway. And career login, this is where going to be like a collection center for all our questions and answers. Okay. This is our only first meeting. Probably it's a little overwhelming for people that hasn't really played with a simulation environment, but I guarantee you're going to get better. Especially once the next week starts, we're going to get into programming. It's going to be a lot more fun. Okay. But then, well, like what Victor said, the first meeting, we're going to focus on using C++. And then we will cover Python later. Okay. I think anything you would like to add, Jeffrey and Victor?
Yeah, real quick. So remember, everything that we talked about in this video or in this webinar is in a video that we released. And we're always going to release videos before these webinars. So yeah, make sure you watch the videos because all the information that's covered in this webinar is already covered in that video. And in fact, the video is a little bit more in-depth. So yeah.
Okay. All right, that's good. That's good. All right. Well, I can foresee that this is going to be a lot more fun, especially when you actually review the video first, because then we can pick up the pace a lot faster. Okay, guys. All right. Thank you for coming, and hopefully see you guys next week. All right. Okay. Thank you, guys. See you next week.
One more thing. Just the error dump that I got sent. Just by looking at it very briefly, it seems to be within an error within the Python scripts that Erebus uses itself. So I assume that's a problem with the Python installation. So for whoever had that problem, make sure that you have the proper version of Python installed. And yeah, that's what I can suggest just by looking at the error dump.
Good, good, good. Thank you. That's what Itash. Okay. All right. Yeah, that's true. All right. Thank you, guys. I'll see you next week. Bye.